this is to be true. Whereas f of x is x squared minus 10, g of x is 5 minus 2x. In short, x squared minus 10 is going to be smaller than 5 minus 2x. Way too hard to solve it straight up, so we are going to manipulate it and turn it into what we're more familiar with. That is a linear or a quadratic. In this case, obviously, it's a square. Let's bring it all to one side and turn it into a quadratic. Then, you can use all the tools you've learned since grade 10, like factoring. Yuck. Come on. Okay? If you didn't use factoring, you're basically wasting all of your past math history experiences. Anyways, you do what you want, but from what I can tell, that we have these, and we're going to look for the zeros, which will help us figure out which parts are under and above the x-axis. This becomes which means so, familiar? So, before I get to this, quickly backtrack and look at this as a whole. We want to see if this function is smaller than that function. That's equivalent to a quadratic is less than a 0. So if we can solve this, we have officially solved that because they are exactly the same, right? So when you see something like that, manipulate it into something that you're familiar with. And I would imagine quadratic is something you're familiar with. Okay? So let's do this. We have x plus 5, x minus 3, negative 5, 3, negative. So positive, negative, positive, positive. So we have between negative 5 and 3, it's equal to a 0. Sorry, at negative 5 and at 3 is equal to a 0, which means, graphically speaking, I don't know exactly what the parabola looks like, but at negative 5 and at 3, I hit the 0 marks. Between negative 5 and 3, it's somewhere under, and under negative 5 is somewhere above, and somewhere above. Right? This is not even accurate. All I know is that negative 5 and 3 are true. So, which of these areas, which part of this domain is under the 0? In other words, when is it under that line? Yeah. If it's under 0 here, between negative 5 and 3, then between negative 5 and 3, this side is smaller than this side. So we're good. Because again, if we satisfy this, then we have satisfied that. The solutions for both equations are the same. So I take this, which is easier, I've solved it, therefore x belongs to real numbers, and please notice that I am not saying it's equal to, because this is not equal to, which means this is not equal to. As long as it's between negative 5 and 3, this is true. That's it. Next question. Great. I'm hoping that people recognize that it's really not the same. Please note, it is not the little 0, it's not the not sign. It is not f of g. It is f multiplied with g. So it's literally. And considering it's a binomial that has the same terms except the addition and subtraction is different, I'm hoping people sort of see the shortcut. The difference of squares. I'm going to do a shortcut. The exact same numbers, but it's a plus and a minus. So I am going to do the shortcut, say 3 minus x times 3 minus x minus 4 minus x times 4 minus x, which is
9 minus x minus.
How dare you? These are their exponents. The bases don't multiply. My goodness. What does that turn into? X to the power of 4. Number 11. That's a good one. Prove their inverses. It basically means you would have to know the definition of an inverse function and know how to prove it. Well, if you look at the answer, it's given to you. But if you want to prove that a function is supposed to be inverses, f of the inverse of x essentially gives you the value itself. And as I said, the analogy that I gave was if you have something that pushes the agenda in one direction, but the inverse pushes it back to the other direction, right? You're back to square one, right? Like for example, let's say this is your starting situation, right? And as the year goes on, you earn a lot of money. So there you are with lots of money. Okay? But then you reverse the process, and in having lots of money, you spend all that money. Now you are back to where you started at. Essentially, that's what functions are, right? We're going with our name, we're going right back. So, let's prove it. That means f of g of x should give me an x. And at the same time, if it's one arrow or the other arrow, you can also say g of f of x should bring me back to my original situation. Let's try it. So in this particular case, we have 3x minus 2, and inside that is x plus 2 divided by 3. Let's multiply it out. We have 3 x plus 2 minus 2, and that equals an x. How about we try this as extra proof? G of f of x is x plus 2 divided by 3, and that f is 3x minus 2, which essentially is 3x over 3, which is x. Inverse functions. Not necessarily complex, except you just need to know what the definition is. Just we're plugging in one function into the other function to see what happens. So honestly, that particular question is not difficult unless you don't know where to start. That's inverse functions. You have to know that word.